Here we have a SAT math problem. Okay, let's go to the question. If the vertex of y equals to x square negative ax positive b as coordinates 2 comma negative 5, what is the y-intercept of this graph in this xy plane? Actually, the given quadratic function is in standard form. When we have a quadratic function in standard form, the constant we have over here represents the y-coordinate of the y-intercept. So our aim is to get the value of this constant b over here. Okay, now let's consider the quadratic function in standard form, that is y equals to ax square positive bx positive c. Okay, when we have a quadratic function in standard form like this, there is a formula to get the x coordinate of the vertex, that is negative b over 2a. Okay, here this b is the coefficient of x, this a is the coefficient of x square. Okay, now let's try to get the x coordinate of the vertex of the given quadratic function. So for that we have to write the coefficient of x over here at the place of b. Here the coefficient of x is negative a. We can plug in negative a for b over here, 2 times a. This a is a coefficient of x square. In our quadratic function, the coefficient of x square is 1. So we can plug in 1 for a. Then I'm getting x equals to negative times negative will become positive, a divided by 2. Okay, here I got the x coordinate of the vertex of this quadratic function. But already we have the vertex over here. So here the x coordinate is 2. So this a over 2 and this 2, both of them represent the same stuff. That is the x coordinate at the vertex of this quadratic function. So we can equate them. Okay, now let me equate this a over 2 and the x coordinate at the vertex over here 2. Now let's solve for a in this equation. For that we have to multiply both sides of this equation by 2. Then this 2 will cancel out. I am getting a equals to 4. Okay, here I got the value of a in this quadratic function. Okay, now let me plug in that value of a over here. Then I'm getting y equals to x square negative. For a, we can write 4, that is 4x positive b. Okay, here there is only one unknown constant b. Now to get the value of this constant b, we need a point on the graph of this quadratic function. So actually the vertex is also a point on the graph of the quadratic function. So we can plug in this point into this equation. That is, we have to plug in this 2, x coordinate 2 for x over here, and the y coordinate negative 5 for y over here. Okay, now let me do it. Then we get negative 5 equals to 2 square and negative 4 times 2 positive b. Okay, negative 5 equals to 2 square is 4, negative 8 positive b. Negative 5 equals to, when I combine 4 and negative 8, I am getting negative 4, that is negative 4 positive b. Let me add 4 to both sides of this equation. When I do so, this negative 4 positive 4 will cancel out. When I combine negative 5 and positive 4, I am getting negative 1 on the left side. On the right side, I am getting b. As I said earlier, this b represents the y coordinate of the y-intercept. Okay, here we got that b equals to negative 1. So the y-intercept always the x coordinate is 0. So the y coordinate is negative 1. So the y-intercept of the graph of the given quadratic function is 0, negative 1. We find this 0, negative 1 in answer choice C. The correct answer choice for this question is C.